Okay, we're looking at differentiation of inverse trig functions. Before we start, this is saying if you differentiate the inverse sine function of x, you get 1 over the square root of 1 minus x squared. So just have a look at that. I'm just going to go to the formula sheet. One sec. Notice the rule is not on the formula sheet. Just the integration is on the formula sheet. Because if you integrate, so actually I'll put them side by side. Here we go. Right, let me just set myself up. So differentiate inverse sine of x, you get 1 over the square root of 1 minus x squared. Look over here for the integrals. 1 over the square root of a squared minus x squared. In this case, compare the a squared with the 1. What does a equal? 1. So in this case, it's inverse sine of x over 1. In other words, it's the inverse sine of x is 1 over the square root of 1 minus x squared. So even though, if you integrate this, you get that. And if you differentiate this, you get that. So basically, because you've got the integral rule, you do have the derivative as well. All right? In this case, a is 1. So the differentiate inverse sine of x, you get 1 over the square root of 1 minus x squared. All right, we're going to look at the... So if we're trying to differentiate inverse sine of x. So let's let y equal inverse sine of x. Can you see this? No, but I'm just going through one of them because there's 6 of them. So y equals... the reason we go through it is the techniques you use are useful in other problems that you may need to solve somewhere in an exam. You just write the first one down or write it down later. So if y equals the inverse sine of x, then x equals sine y. Remember, we're trying to find dy dx, aren't we? If y equals inverse sine of x, x equals sine y. Why am I allowed to do dx dy? I'm differentiating with respect to what? Y. So I'm allowed to do dx dy because it's sine y over here. So dx dy is just the derivative of that. See, girls, you're used to seeing y equals sine x, dy dx, and you can differentiate. I've got x equals sine y. So remember, it's d whatever on the left by d whatever's on the right. So dx dy is differentiate sine, you get cos, right? But I don't want dx dy, I want dy dx, so it's the reciprocal of... So it's basically 1 on cos y. If dx dy is cos y, then dy dx is 1 over cos y. Are you okay with that? But they've got 1 over dx dy, which is true, which is 1 over cos y. Are we good? Now, that's what dy dx is. It's 1 over cos y. Starting again, sine squared y plus cos squared y is 1. We know that from 2 units. You know, sine squared x plus cos squared x is 1, or sine squared theta plus cos squared theta is 1. Therefore, cos squared y is 1 minus sine squared y. Now, reason we're square rooting is that I've got dy dx equals 1 over cos y, and I want to make it in terms, I need to go 1 over cos y, not 1 over cos squared y. So therefore, cos y is the square root. We're square rooting both sides. Cos y is the square root of 1 minus sine squared y. Now, we've defined sine y earlier in the question. You can see up here. Cos y is the square root of 1 minus sine squared y. We know that sine y is x, so it's 1 minus x squared. That's what cos of y is. That's what cos of y is. Therefore, dy dx is 1 over cos y, which is 1 over the square root of 1 minus x squared. All right? Now, we're not going to prove any others. All right? So that's the first one. Looking at the second rule. This is the one that you see on your formula sheet. Girls, if you're differentiating the inverse sine of x over a constant. Now, I'm going to show you 2 ways to do this later. It is 1 over the square root of a squared minus x squared. Now, that rule is not on the formula sheet. What is on the formula sheet is the integration. So just locating that. If you integrate 1 over the square root of a squared minus x squared, then you'll get the inverse sine of x on a plus c. So if you differentiate inverse sine of x on a, you get 1 over the square root of a squared minus x squared. Okay? So that rule is there, but you need to look at the integrals to find it. All right. Written it? All right. And there's another proof. We're not doing it. Right. Next rule. I'm not doing the proof. We're only doing one proof. The next rule is, if you differentiate inverse cos of x, it equals negative. Okay, this one's not in there. So, the reason is, yeah, but it's negative. Yeah, it's negative. Look at inverse sine of x on a. It's 1 over the square root of, let's say a is 1 minus x squared. Let's look at the proof to see why. If you differentiate inverse cos of x, you get negative 1 over the square root of x squared. Now, let's look at the proof for this one. It'd be good to look at. It's all going to come about because of this sine squared plus cos squared thing that we do later. All right, if you let y, you don't have to write this down if you don't want, you can just look. If y equals, we're trying to differentiate inverse cos of x. If y equals inverse cos of x, then x equals cos y, which means that dx dy, there's your negative, is negative sine y, because if you differentiate cos, you get negative sine. Now, dy dx, therefore, will be negative 1 on sine y. If you're jumping from there to here, dy dx is negative 1 over sine y. We then again do this sine squared y plus cos squared y is 1. Therefore, sine squared y is 1 minus cos squared y. Sine of y square rooting both sides, 1 minus cos squared y, which is the square root of 1 minus x squared. Therefore, dy dx is the negative 1 over sine y, negative 1 over the square root of x squared. Square root of 1 minus x squared. Good? Why is it negative? Because if you differentiate cos, you get negative. All right, negative sine. Okay. The other rule, now you're rarely ever going to get given just inverse cos of x. You're going to be given x on 2 or 2x or something like that. Let's just look at this side by side with this other one. If you differentiate the inverse cos of x on a, you get negative 1 on the square root of a squared minus x squared. Where do we see that rule? We can't see it, but we have to know the relationship between the cos, inverse cos, and inverse sine integration and differentiations. So that one's not on there. So the sine one, I suppose, keep the sign the same again. And the cos one's got the different sign. You know how sums and differences? Look, girls, this. Do you remember this? Sine. Sums and differences, keep the sign the same. Cos, you change the sign. Look at this. Differentiate inverse sine, keep the sign the same. Differentiate inverse cos, the sign changes. Negative 1 over. All right, girls, so you won't see that on the formula sheet. You'll have to remember that one. Are we okay? All right, now I'm going to do some examples. I'm going to show you 2 ways, and then we're going to stick with the one method. One more, sorry. Last one. If you differentiate okay, this one's a little bit tricky. If you differentiate the inverse tan function, you get 1 over 1 plus x squared. Let's look at it here on the formula sheet. In this case, a would be 1. So we're just differentiating 1 over 1, which is 1, inverse tan of x on 1, which is inverse tan of x. So if you differentiate inverse tan of x, you get 1 over 1 plus x squared. Are we okay? Remember, that is the integral. If you integrate the left, you get the right-hand side. If you differentiate the right-hand side, you get the left-hand side. Now, that's the normal one for when a is 1. They've got the proof there, similar sort of thing, with sec squared, etc. The next rule is if you differentiate the inverse tan function of x on a, you get a over, wait a sec, over a squared plus x squared. We've got, okay, yep, this is fine. This is fine. You tell me why it's fine. Why that is the same as what's here. Because see this a down here? Where did it get moved? Where have they moved it? Up there. See this 1 divided by a? This a goes up the top. That's why they've got that. Okay? So when we do these types of questions, we want them to look like 1 over if we're going to stick with the formula. All right? So when we come to those, we'll look at that. So there's going to have to be some manipulation done if we want to work with this. Okay? But they are the same formula because that's just d by dx differentiating inverse tan of x on a. If you differentiate inverse tan of x on a, well, I need to move this 1 divided by a. Divide by a means times a on the other side. That a goes up there. So be very careful with that. All right? When you're differentiating. All good? All right. You might want to write what's on the formula sheet as well. Yep. But that's all you'll have. So just be careful if you're using the formula sheet for the tan, that a goes up there. All right? Unless you're differentiating something of that format. But we'll get to those when we do them. The first question that we're going to look at is to differentiate. So up the top is the formula. So you're not given that formula. What you're given here is on the formula sheet. If you differentiate the inverse sine of x on a, you will get 1 over the square root of a squared minus x squared. But if you differentiate the inverse cos 1, remember it's the negative. So that's the rule up the top there. If you differentiate inverse cosine function, you get 1 over, negative 1 over. Now, in this case, girls, we've got to be really careful here. What is, girls, that doesn't look like x on a to me. Why do you think they're doing what they're doing? So I'm going to do over here as well. So I've got y equals inverse cos of 2x. I want to find dy dx. You can just set it out like this. The rule is negative 1 over the square root of. Isn't the rule negative 1 over the square root of a squared minus x squared? In this case, girls, my question is not set out. So let's just look over here. What does x on a equal in my question, girls? 2. X on a is 2x. So what's a? So I'll just get rid of the x's. So what I've got, where I should have an x on a, I've got 2x, yes or no? So therefore, what does a equal? Yeah, so therefore a, I'll put it on the other side if you want, is a half. Because if I put the a up there and the 2x down there, look what I've got. So a up there, 2x down here, a is 2x on x, in other words, a is 2. But girls, you don't need to know that. You need to see that x divided by a half gives me 2x. Look, a is a half. Yeah, a is a half. So just be careful, please. You know how many people will put that a is 2? A lot of people will put that a is 2. You need to look at the formula, and it has to be, this is why I don't like using this method. I want to use the other method. I really want to use the other method, but I'll just show you. If you are going to use this method, there's lots of questions where you can't use it. You can use it here, because we might ask you for the inverse cos of 2x plus 5, and you can't use this method. All right? So we're going to go to the other method in a minute. All right? But if you are going to use purely the formula sheet, I would only use the formula sheet if the question was inverse cos of x on 2, for example. That would be really easy, because a is 2 in that case, and you've got 2 squared minus x squared. Do you get that? In this case, x is a half. So you can do it like, sorry, a is a half. So it's negative 1 over the square root of a half squared minus x squared. The bad thing about this method, you've got a lot of stuff that you've got to do. Now I'll do it over here. So it's a half squared minus x squared, which is negative 1 over the square root of a quarter minus x squared. Look what they've got to do here. It's so much work. And it's not worth it. It's not worth it to do all this work. They've now gone common denominator. They had a quarter minus x squared. They've gone a common denominator of 4, which is 1 minus 4x squared on 4. This is all under the square root sign. You can see how much work this is, right? If you don't mess up the half, people might mess this up. So we're not going to do this method again. What else do I do now? So it's negative 1 over, we've gone common denominator. Girls, that's the square root of the numerator over the square root of the denominator. What does this denominator become here? So I've got negative 1 over the square root of 1 minus 4x squared divided by 2. Look, I've now even got fraction divided by fraction. So this is just not good. Where does this 2 go? So this is not the method to use. Definitely not. We are not using that method. All right? We're going to use the simple method. The method that works for everything. For differentiating sine functions, cosine functions, exponential functions, log functions. If you're not quite differentiating what you want to be differentiating, you use the function of a function rule or your chain rule or whatever they call it. So, much easier. You just put in, so this is what we're going to do. We're not doing that. We're doing this. Much easier. So, if y equals the inverse cos of 2x, I know what the rule is for differentiating that. It's negative 1 over the square root of 1 minus x squared, if that was purely just an x, of 1 minus 2x squared. See, what's in place of my x? It's 2x. So I apply the rule as if this is just y equals inverse cos of x. Thank you. Is negative 1 over that? You say, geez, I wish that was x. If it was, I'd do that. But girls, when you're differentiating and it's not what you want, isn't the rule then to differentiate what's in there? Times the derivative of that. Times 2. Times the derivative of 2x. So it's what we've done for logs. It's what we've done for differentiating exponential functions. If you're differentiating, and we'll look at those in a sec, you apply the rule and then you just times by the derivative if you don't have a pure x. Okay, so therefore this answer is negative 2 over the square root of 1 minus 4x squared. How much simpler is that? This, girls, is the derivative. Differentiate. Can you write differentiate 2x? Differentiate the 2x. Much easier. Girls, just going to make the other method's just a mess. So we're just going to use this one.
Miss, why does the other method exist?
Because I'd only use the other method if I was asked to differentiate inverse cos of x on 2 or something like that. That's much easier. That'll come out really clean.
Yeah.
So we'll do one of those in a sec. In this case, you're considering over a to be 1 in this case. Because look at the formula sheet. It's inverse sine of x on a. We're taking the a to be 1 here. All right, just be careful here. We're taking the a to be a 1. So we're taking that as 2x on 1. So we're putting the 2x where the x should be, but we know we've done the wrong. Like, you're not allowed to just do that. If you do that, you just differentiate. If you're applying the rule for x when there's not an x, a pure x there, you just do the derivative of what you've just substituted. All right? That is the easiest way to do it. It's on the formula sheet. This is what's on the formula sheet. That if you differentiate sine to the minus 1 of x on a, if you differentiate that, you get 1 over the square root of a squared minus x squared. That's what's on the formula sheet. It's actually the other way around, but that's what you get. So what are you going to do, girls? what are you got to consider your A to be? And that 4 has got nothing to do with this A. All right, that's if you're going to use the formula. Remember, to use the formula, you're going to do about 10 lines. We don't want to use the formula. Unless your algebra is absolutely spot on, I wouldn't be going with that formula. I'd be going with this and pretending that A is 1. All right? So I get 4 times, if you're differentiating 4 tan x, you get 4 sec squared x, because the 4 is just a constant, it stays there. So it's 4 times the derivative of the inverse sine of x. Now the inverse sine of 2x is what? The derivative of the inverse sine of 2x is what? 1 over the square root of what? 1 minus 2x squared times, differentiate the 2x and you get 2. I will do it with the formula in a minute, and you've got to decide. See, if I'm doing it this way, I'm doing 2x over 1. My A is a 1.
Is A always 1?
If I'm going to treat it like that, yes. Yeah. All right, I'll see. We'll look at some other examples. Now, 4 times 2 is 8, so I've got 8 over the square root of 1 minus 4x squared. I'm going to do the other method. Let's do the other method. If y equals 4 times the inverse sine of 2x, let's do the other method. That's the same as saying y equals 4 times the inverse sine of x over a half, right? If you want to use the formula. The formula's over there. dy dx equals, are we okay? If I want to use the formula, and it's up there, it's 1 over the square root of what? If you want to use the formula like this, if you decide to work out what A is, what am I going to put in, girls? A half squared minus x squared. So I've got to put my 4 there, by the way. 4 times 1 over square root of a half squared minus x squared. I don't know if you want to go this way, I don't. So it's 4 over the square root of what? A quarter minus x squared. Now what do I got to do? Common denominator. Do you really want to use this method? 1 minus x squared on 4. Square root of 1 minus x squared stays the same. Square root of 4 is 2. I have to end up putting that 2 up there because I'm dividing by 2. See, it's 4 divided by the square root of 1 minus x squared over 2. We don't want to do this method, girls. And it becomes, now, you can either take 5 lines or 2.
Instead of the x squared, don't you tell it by 4 if you do common denominator?
No. Yeah. Oh, yeah. Thank you. Common denominator, 1 minus 4x squared on 4. Are we okay? That's a 4. We don't want to do this method. Do you want to do this method? I don't. If you like that method, go with it. But just be very careful. If you're going to use the other method, I'll just show you when you might have troubles with that method that you want to use. We ready?
Yeah.
All right. Tell me how we're going to do this one if you want to use the other method. If y is the inverse sine of x squared, how, using the other method, are we going to do derivative of inverse sine of x squared? The formula sheet only has this, and it doesn't cater for it. Girls, this type of question doesn't cater for the formula. Yeah, how do you do it? Girls, this is a function of a function rule. You do the normal rule for x squared. This would be over 1. So you can't use that method that you want to use. There's no x on A at all. You're not allowed to. This rule is not for x squareds. It's just for x's. So what are we going to do? We're just going to use it as, we're going to do what I was just doing. So we go, A is 1. All you need to know is that in this place you've got x squared and A is 1. It's much easier. It's 1 over the square root of what, girls? 1 minus x squared times 2x. Okay. Which is it's one line. 2x over 1 minus x to the power of 4. Isn't that much easier?
Yeah.
Don't use the other method.
Yeah, I meant I do that.
Yeah. So we're not doing the other method anymore. We're not looking at it. Okay, another one. If y equals, we're going to do a tan one. dy dx. We've got the formula. Do you have your formula sheets? Here's the formula. Integral of 1 over a squared. We've got to be careful with this one.
Why do you write that on the side?
Because you'll have your formula sheet.
But why does it look that that's integrating?
I know, because if you're given an integral, you're automatically given the derivative. Do you know how? If you integrate that, you get that. Georgia?
Yeah.
And if you differentiate that, you get that. So girls, what am I going to do with this? What are we going to do? Do we have, yep, all right, we've got to be very careful. We're just going to pretend that the A is 1. All right, and that A is 1.
No, you just square the whole bracket. When you put it 1 over.
Okay, yep. So you go 1 over 1 plus 2x minus 1 squared times, differentiate 2x, and you get 2x minus 1, and you get 2. Much easier. So girls, we're going to consider that A's are 1. Yeah. So it's 1 over 1 plus 4x squared minus 4x plus 1. And then we've got a 2 on the numerator. Sorry about that line going down. Which is 2 over 4x squared minus 4x plus 2. What can you do with each of those? You can pull out the 2. In other words, you can divide everything by 2, or you'd factorise out 2 on the denominator, and you'd end up with 1 over 2x squared minus 2x plus 1. Do you know why? Because yes, you will. But girls, when everything is even, you just divide everything by 2. That's the same as doing the following. That's the same as going 2 over 2 bracket 2x squared minus 2x plus 1. The 2's cancel, you see? And you've got 1 over 2x squared minus 2x plus 1. Okay? When you're given something that is identical to the formula sheet, or we'll have a look at this one. You could, but the formula sheet has 1 on A. Where do you put, all right, here's your formula sheet.
A then 2.
Yeah, don't you then, you're trying to, if you integrate this left, you get the right-hand side. If you differentiate that, you get that. I don't have a 1 on A here, so let's put that A up there. What do you get? So girls, integrate this, you get that. Differentiate that, you get that. I don't have a 1 on A. Let me put that A up here, because I'm differentiating just tan to the minus 1 of x on A. If it looks identical to the formula sheet, use the formula. Got it? But if you've got x, A is a half, you're not using the formula. Do you see what I'm saying? So if it's exactly the same as the formula, I would use the formula. Because then you're going to get into trouble going the other way. What do you get, girls? This A has to go up there. Do you see why? So what do I get? 2 over. No, I'm not differentiating a half tan. I'm differentiating inverse tan of x on A. That A goes up there. The A is 2 this time. It's 2 over what? 2 squared plus x squared is 2 over 4 plus x squared. If you want, we'll use the other method. All right, let's try the other method.
Is this an arrow rule?
Differentiating 1 over A. All right. Girls, do you know why I put the 2 up there? Do you see that the rule is to differentiate 1 on A, or just put the A up there?
Could you still do that the other way?
Yeah.
All right, let's try it. All right, let's try it the other way. What is it? dy dx is, it would be 1 over, in this case, A is 2. Oh, jeez, I don't like doing it the other way.
It's okay.
Don't you do a half?
You go 1 plus
X on 2 square, oh no, what's the rule? A,
1 x on
1 plus 1 squared plus, so that's plus x on 2 squared, is that what you're saying? Times a half. All right. So you're taking that all over 1, like your A is 1. See, I think, girls, when it looks like the formula, use the formula, you're now making a big mess. Do you see that? The only time you use the other method if it doesn't look like the formula. This is not the way to go with this. You're now making the mess that you had with the other one. You use the formula when it looks like the formula. Whatever. So it's 1 over 1 plus x squared on 4 times a half. I have to go, where does that 2 go, girls? 2 bracket 1 plus x squared on 4, don't like this. 1 over 2 plus x squared on 2. See what we're doing? And now multiply everything by 2. No, guys.
It works with common denominator.
I know, but it's much easier just to multiply numerator and denominator by 2. 2 over, if you multiply that by 2, and you 4 plus x squared. Now, really, look at all that compared to this, using the formula. You use the formula when it looks like the formula. You use the other method when it doesn't. Got it? That's doing what we were doing with the other ones. Look, you're only going to get one question on it. So pick one method. If you want to use the formula, fine, but you've got to do all that square root stuff and move things. If you feel you're going to get confused, stick with the formula with the A. Get what I'm saying? And yes, you've got to do about 3 lines of manipulating. All right, do we sort of remember what the rule is? Because I can't. What happens if y equals 3 sine to the minus 1 of x on 6? Would you stick with the rule for this one?
Yeah.
Because it's x on a.
Yeah.
What is the rule? Oh, I've got it in front of me. So this one looks like the rule. So we go with the rule. Do you get that? But of course we leave the 3 there. This is the rule. We like that one. So it's going to be 1 over, but it's going to be 3 times 1 over the square root of a squared plus, no, minus x squared. That one we go with the rule. 3 over the square root of 36 minus x squared. So sometimes yes, sometimes no. Give you another one. Y equals inverse cos of the square root of x. Rule or no rule? Don't use the rule. A is 1 in this case. Inverse cos is the negative of the sine one. Negative 1 over 1, no. Negative 1 over the square root of 1 minus what? Square root of x squared. Negative 1 over the square root of 1 minus x. No. Yes.
And then you can time.
Oh, did we differentiate? No. Times it by derivative of x to the half is a half x to the negative a half. You know, x to the half, you have to differentiate it. So this is x to the half. You differentiate it, you bring the half to the front, x to the negative 3 to the negative half. A half minus 1 is negative a half. So times 1 over what? 2. The square root is down the bottom. So it becomes negative 1 over 2 root x times root 1 minus x and I'd keep it. Ooh, ooh, ooh.
And then the root x goes inside. The root x goes inside.
Oh, yeah.
Minus x.
One sec. The square root of a times the square root of b is the square root of a times b. So I can write it as -1 over 2 times the square root of x bracket 1 minus x. Do you see what I've done? The square root of a times the square root of b is the square root of ab. So I can write that under one square root sign. There's only one square root sign. There's not square root within square root. All right? I'm just looking for some others. All right, let's do product rule. Ready? If y equals x times inverse cos of x, u equals x, u dash is 1. V equals inverse cos of x, v dash, that's the negative of the sine one, a is 1, -1 over the square root of 1 minus x squared. Let's go. uv dash or vu dash? Plus vu dash, doesn't matter because it's positive, plus u times v dash plus v times u dash, which is what? How do you simplify the first one? Just what's on the numerator? Negative x over the square root of 1 minus x squared plus the inverse cos of x. Done.
Oh, so you just leave it like that?
Yeah, you can't do anything with it. Another, so that was question 1F from your exercise. Yeah, this is the next exercise. If y equals inverse sine of cos of x, find the derivative dy dx. Girls, that's why we're doing the second method. Your x in this case is cos x, do you remember?
Yep.
The sine one is on the formula sheet, it's not the negative one. Replace your x with a cos x, and a is 1. All right? Just got to practice them, girls. All right? And you're lucky you've done them last, because that'll be the freshest thing in your head. That's right. So we get 1 over the square root of 1 minus cos x squared times the derivative of cos x is negative sine x. So therefore...
Did we say anything about 1 minus?
So girls, how do I write 1 minus cos x squared? Isn't that... You write that as 1 minus cos square root of, yep, this is good, minus sine x over the square root of sine squared x, which is negative sine x over sine x. Nice question. -1. If y equals the inverse sine of ln x, find dy dx. Remember, we're just using the rule. This is question C. 2C, 3C, 2C. Are we good?
Yeah.
1 over. A in this case is 1. The square root of 1 minus ln, do not write ln x squared, times, differentiate ln x. Thank you. And that's on your formula sheet. Don't want to get that one wrong. Because, yeah, if you integrate 1 on x, actually, is it on the formula sheet?
Yes, it is.
Yes, it is.
Oh, yeah.
Miss, didn't the ln x squared that just say the same?
That's, yes, I would just leave it exactly like that. Don't touch it. So it's basically 1 over x times the square root of 1 minus ln x squared. It's not 2 ln x.
No.
It's not ln x squared. It's none of those. You leave it like that. because it's ln x times ln x, and there's no rule for that. There's a rule for ln x plus ln x. What's that? What's ln x? It's, no. Yes, it is. That's right. ln x plus ln x, girls, ln, if I gave you ln2 plus ln3, how do you do that one?
ln 2 times 3.
Yeah, it's ln6. So if I give you ln x plus ln x, this is not what this is. It's ln, no, what did I do with the 2 and the 3?
Oh, x squared.
So, yes, which is, of course it is, because it's 2, it's like algebra. 2 ln x. All right, so yes. So using that rule or using algebra type things, it's 2 ln x. All right, that one's done. I'll send you another video.